product, that is alpha c. This is defined by like that. This alpha c is basically a set, and that set is the collection of all z elements such that z is equals to alpha of any x, where x is belonging to that set c, and alpha be the real one, okay, and x be the element of that Convex set c. Okay, and here if we assume that any two element of this alpha c, so here z will be the element of that alpha c. So if we assume that any two elements, suppose z1 and z2, that belongs to that set, that is alpha of c, then if z1 belongs to that set alpha c, this means here for any alpha belongs to r and x1 belongs to c, this means z1 equals to alpha of x1, that is also belongs to that set alpha c. Okay, so this means z1 is equals to alpha of x1, and similarly z2 is equals to alpha of x2, where these two elements x1 and x2, these two elements belonging to this convex set C, and of course alpha is a real number. Okay, so here we have to prove that the convex combination of these 2 points is belonging to that set alpha C. So what is the convex combination? So if we take the parameter, so if we assume that for any theta which lies between 0 and 1, this parameter theta, we have checked that uh, convex combination of these 2 points, so theta of z1 and 1 minus theta of z2. Okay, what is the value of this, and uh, this belongs to what set? Okay, so here this equals to alpha. What is z1? Z1 is alpha of x1. Similarly, plus 1 minus theta. What about z2? Z2 is alpha of x2. Okay. So if we take this alpha is common here. So alpha, if you take common, so here you can get this alpha and theta both are real numbers. Okay, so alpha into theta and theta into alpha is same. Alpha into 1 minus theta and 1 minus theta into alpha is same. So that's why we take this alpha parameter is common. So here take the scalar multiplication of this x1 plus 1 minus theta x2. Okay, so you finally get this thing. Okay, and you know that this C is convex. Convex means convex set, and this x1 and x2 is belongs to that set C, and C with a convex. Then you know that any set is convex, and if we take any 2 points x1 and x2 that belong to that convex set, so convex combination of these 2 points is also belonging to that set C. Okay, because C is convex, that's why this condition holds. Okay, and here you know that any point is theta x1 plus 1 minus theta x2, okay, where this theta belongs to those intervals 0 and 1. Okay, so this is a point for any value, particular value of theta. This is a point. Okay, so if this theta of x1 plus 1 minus theta x2, this point belongs to that set C, and alpha is belonging to R. Okay, so any point which belongs to C and alpha belongs to R, then alpha of x is belonging to that set alpha C. Okay, so here this point is belonging to C. This is a point. Okay, and this point is belongs to the set C. This element alpha is belonging to R. This belongs to R. Okay, so here you know that if any alpha belongs to R, this belongs to R, and this set belongs to set C, then this product of that two is belongs to that set alpha C. That's why this belongs to set alpha C. So here, to prove that this theta of Z1 plus 1 minus theta of Z2, this belongs to this set alpha of C. Okay, so here we take this any point Z1, Z2 that belongs to that alpha C, and for any theta which belongs to 0 and 1, the bonus combination of these 2 points belongs to alpha C. So this implies that this alpha C is convex set. Okay, so this is the proof. Okay, so similarly, if we take this real alpha, is if you suppose this alpha is, if we take any real number, suppose 1 by beta here. Okay, this means if you're dividing by any scalar real R C over beta, if you multiply by this or dividing this, this is also convex set. Okay, so now next one is what is affine set? Okay, so affine function, affine set and affine convex set already we had discussed. So next one is what is affine function, and then we go through what is convex function and what is the properties of that affine function and convex function. So next page, so next page we define here affine function. Okay, so any function, we say that a function f is said to be affine. This function is from any Rn to Rn. Okay, and that function is said to be affine if it has the linear form. It has the form. That form is linear one. That is, we take fx equals to this form ax plus b. Okay, where this A is a matrix which belongs to n cross n, and here B with a column vector Rm. Okay, and what is your x is belongs to Rn. Okay, so that is basically you say that this ax plus b, this means it is the sum of the linear function and a constant. Okay, so that is, you can say that this affine function. Affine function is basically, it is a sum of linear function and a constant. So if we suppose that any set which is in Rn, suppose if we take this set is Sn, and this set S is it belongs to Rn, and this set S is convex. Okay, so we can assume that this is a convex set. This is S with a convex set. Okay, and we define a function like with f1 the function, and this function is from Rn to Rm, and this function is an affine function. Affine function. Okay, so then what is the image of this this S is the subset of this Rn. We define a mapping F1, and that mapping is affine. Okay, so this means what is the image? That image is like in this Rn. So this image means F1 of S is F1 of S. This is basically you say that image of this set S under the mapping or transformation is under this F1. Okay, so here S will be your set. Okay, this under F1, and this is basically defined as the collection of all F1 of X, such that your X is the element of that set S. Okay, so what is the image of that? So if this function is affine, this means if we take here is this is your suppose S, this is your set, and this is subset of Rn. Okay, and here this set S, if we take any element of that set S, and we define that the image of that function. Okay, so if we take this is your any image of that. Suppose if you take this T, and T is the uh, set in Rm. Okay, this is Rm. Okay, so this is suppose a mapping, your mapping, and if this mapping is defined by F1. Okay, and this goes to this element, suppose y, and this is your x. Okay, so x be the n dimension and y be the n dimension. And here, what is the set T? T is the basically this is the image of your set S1. Okay, so here this is given that if this set S, if this X is convex, this is convex set, this is convex set. Okay, then this implies that your this image of this set under affine transformation, this is TB also convex. So T is convex. Okay, convex, or we say that only convex, or right convex set. Okay, similarly, if we take another transformation, okay,
Image of image of
okay, then
F1 is image of
क्या क्या आवाज क्लियर नहीं है, फिर से बोलें.
then F1 is image of
Image of S under F1.
okay.
ओके, एक सेकंड मैं इसको थोड़ा image of S under this transformation. Okay, so similarly, if we define another function, suppose F2. Okay, and this F2 is basically this is F2 inverse of S, and this is the collection of all Z such that F2 of Z, this belongs to S. Okay, okay. So this means you take another set here, okay, and this is suppose this is your element Z here, and this is for suppose if you take this set is M, and that is a subset of any other dimension. Say if you take this is in k dimensional. Okay, so here this is right here. What is the F2? F2 is a mapping from this to this. Okay, this mapping is F2. Okay, and here this mapping from F2 to this set, this mapping is F2 inverse. Okay, so here you take this this F2 inverse S, if this F2 inverse S means this function F2 inverse S, this is your Z, this is your Z, and here F2 of Z, this will belongs to this F2 of Z, this belongs to your set S. Okay, तो यहाँ पे ये कह रहे हैं कि if the inverse image of okay, so similarly if we can write here okay, तो इससे पहले हमें चलिए यहाँ पर मैं इसको और एक्सप्लोर कर देता हूँ. So similarly, if we define what is F2, direct हम ये इमेज ना लिख करके define करने what is F2 here. Okay, so if your F2, similarly if this F2 is mapping from this RK to Rn. This is RK to Rn, and this F2 is affine. This is affine function. This is an affine function. Okay, so the inverse image of S, the inverse image of that S under the mapping F2, that is this equals to this means this is F2 of inverse, and this equals to the collection of all Z such that F2 of Z belongs to this. Okay, so this image of S, under this F2 inverse. Okay, so this is the inverse image of S under F2. This is also convex. This is convex set. Okay, so this means here you say that if this is convex set, then the image, if F1 is image, if F1 is a affine function, then the image of that S is your convex set. Similarly, if this is convex set, and a mapping which from here to here, which is defined is affine function, then the inverse image of that is also convex function. Okay, so here M is convex. M भी हमारा कॉन्वेक्स सेट होगा. इफ S इज कॉन्वेक्स सेट हो, X में कॉन्वेक्स सेट है, और यहाँ से हम इसकी अगर अफाइन फंक्शन डिफाइन करें तो इसकी जो इमेज होगी वो भी हमारी कॉन्वेक्स सेट होगी, और यहाँ से अगर हम इसकी इनवर्स फंक्शन हम डिफाइन करते हैं, उसकी इमेज लेते हैं, बशर्ते वो फंक्शन हमारा अफाइन हो, F2 मेरा अफाइन हो. ओके, तो इसकी जो इनवर्स इमेज होगी वो भी हमारा कॉन्वेक्स सेट होगा इफ S इज कॉन्वेक्स सेट. ओके, तो यहाँ पे आपके F1 एंड F2 यहाँ से जो दिए हैं, यहाँ पे आपका F1 जो है दिस इज योर अफाइन फंक्शन. ठीक, और यहाँ पे आपके F2 जो है वो हमारे क्या है, अफाइन फंक्शन. ओके, तो ये है, तो इसकी जो F2 इनवर्स इमेज है वो भी हमारी कॉन्वेक्स सेट होगी, और यहाँ हमारी F1 ऑफ S ये मेरी कॉन्वेक्स हमारा सेट होगी. ओके, सो दिस इज simple relation between what is affine function, and if we take the set is convex set, then our image and inverse image are also this is convex set. Okay. So next page we take what is convex function. Next one is convex function. any function f, a function f that is from real value function, that is R into R, is convex if the domain of f, this means domain of f is convex set, convex set, and if for all, if we take 2 points, suppose x1, y1, x1, x2, or x and y, we take 2 points, which belongs to this domain of f, and with condition this theta lies between 0 and 1. So we have this f of this theta of x plus 1 minus theta of y. Okay, this is less or equals to theta of fx plus 1 minus theta of fy. Okay, so either we take x1 and x2 two different points, or we take x and y. Okay, so suppose this is a okay, suppose this is equation number 1. Okay. So a function f is strictly convex, strictly convex if this strict inequality holds. If the strict inequality holds in equation number 1, holds in equation first. Okay, so this means this f of the x plus 1 minus theta of y is strictly less than theta of fx plus 1 minus theta of fy, and here this x and y are not same. Okay, so you have to remember that here x and y are not same, and of course if theta equals to suppose 0, if we take theta equals to 0, so this becomes fy and fy. So here your theta is also by between strict equal to 0 and 1. Okay. So this is for strictly convex function. Okay, so this is for a convex function, and this is for this condition holds for strictly convex function. Okay. And what is concave function? So if we define, we say that if we are able to prove that this minus of f, this minus of f, this is convex function. This is convex function. If minus of f is convex, then f is concave. Okay, and similarly, the strictly concave is if minus f is strictly convex function. Okay. So, and strictly concave if minus f is strictly convex function. Okay. So here, equation 1, equation 1, if we take this f of theta x plus 1 minus theta y is less or equals to theta of fx and 1 minus theta of fy. So this is the mathematical representation of your convex function. If any xy which belongs to any domain, and remember that that domain is convex set होना चाहिए. सबसे पहले तो हमें जो जिस domain में function defined है, that domain should be convex function. Okay, तो ये हमारी convex function होने चाहिए. तो ओके, तो हम ये देखें कि दिस इक्वेशन 1, what is the geometrical representation or geometrical meaning of this equation number 1. Okay. So here if we try to draw the graph of this equation number 1, so here if we take suppose this is your partition form, if we take in 2 dimensional. Okay. So here, if we take any two arbitrary points, suppose if we take this point is first one, and suppose we take this point is second one. If this point is x and this point is y. Okay, not x1, x2. We take in other form x and y. Okay, these 2 points. Okay, and here, what is the representation of this theta x plus 1 minus theta y? If we take this is x point and this is y point, so what represent this thing? Theta of x plus 1 minus theta y. Theta x plus 1 minus theta y, when theta lies between 0 and 1, this simply represent the line segment that joining these 2 points x and y. Okay, so for any theta which lies between 0 and 1, so this means this are the whole point that represent our, this is theta of x plus 1 minus theta of y for any theta that belongs to 0 and 1. Okay, so this means this represent basically the line segment xy. Okay, so what is the f of that? F of that means image of each point, means each point के आपको images देंगे. Okay, so this means if we draw the image of that, okay, so suppose any function like this. Okay, so this is your function. Okay, suppose if we take this type of function which goes from here to R. We take suppose this type of function. Okay, so here what is f here? Here f is this is your f, this is your function f. Okay, and the image of this point is this thing, image of this point is this thing, and before that this is the image of that, here this is the image of that. This f is basically the image of this. Okay, okay, and here what is the value of this point? What is the image of that? This point is image of this point is fx. What about the image of this point? This point is image of f of y. Okay, so and here this in this point, this is the f of theta x plus 1 minus theta y. So this whole collection of this line segment will represent this function nature of that. Okay, so this is this f of theta x plus 1 minus theta y. This is basically this thing. Okay, so what is this portion is, you can write here, this is the f of image of this point, and this point is theta x plus 1 minus theta of y. Okay, and now we take the right hand side. Right hand side is fy, and fx in the form of that. Fx be a point, okay, and fy be a point. Yeah, fx is a point and fy be a point. And we take this parameter theta and 1 minus theta, where theta lies between 0 and 1. This means here this is a point, fx be a point, and fy be also a point. And we take the convex combination of these 2 points. This means this represents a line segment that joining the fx point and fy point. So this here, what is fx and fy if we're joining these 2 points by a straight line. Okay, so this is this thing. Okay, and what this line represent the convex combinations. This line segment can be written as the convex combination of these 2 points. This point is fx and this point is fy. This we can write 1 minus theta of fy. Okay, so this green portion is theta of fx plus 1 minus theta fy. This is the line segment. Okay, and here this blue portion is the image of this point, this joining these 2 points x and y. Okay, so here you put that this is the image of that 2 point. Okay, so equation 1 says that this right hand side means this functional value f, this functional value at this functional value at point this theta x plus 1 minus theta of y. Okay, and the image of that is simply right in by the curve, and this image is basically represented by this blue line. Okay, blue line represents basically f of theta x plus 1 minus theta of y. Okay, and here the right hand side, this line you see that at this point fx this point and this point are coincide. Okay, and fy this point is coincide. Okay, so this is either, and otherwise this green line is always greater than this value of that is greater than this blue line. Okay, so this means this is less or equals to, this sign is less or equals to this green line. The green line represents theta of fx plus 1 minus theta of y. Okay, so this basically equation number 1 says that if the curve, if any curve हम ले लें और किसी भी दो पॉइंट को अगर हम ज्वाइन करें और वो जो स्ट्रेट लाइन है, if this straight line is above that curve, then this function is said to be convex function. Okay, तो basically आप तो मैथमेटिकली तो आप प्रूफ ऐसे कर ही सकते हो बाय इक्वेशन 1 यू कैन प्रूव दैट एनी फंक्शन व्हिच इज कॉन्वेक्स और नॉट, बट ज्योमेट्रिकली भी आप किसी फंक्शन को देखें और ये बता भी सकते हो कि वो फंक्शन जो है, वो फंक्शन हमारा जो भी हम ग्राफ है वो हमारा कॉन्वेक्स है या नहीं। उसके लिए आप क्या करें, किसी दो पॉइंट को आप ज्वाइन करें और उनको मिलाने वाली जो लाइन है, इफ दिस लाइन इज अबव देन दिस कर्व, so this is a convex function, otherwise this is हो सकता है कि ये आपकी कॉन्केव हो या नहीं हो सकती है। तो कॉन्केव के लिए क्या होगी, तो कॉन्केव के लिए हम अगर देखें तो हमारी माइनस ऑफ एफ मींस इसका बिहेवियर सेम हमारा रिवर्स होगा। फॉर कॉन्केव फंक्शन इफ यू टेक suppose 2 points here, and if we take this point is x and this point is y, okay, so any curve which of type suppose like this, okay, here what is the image of this x, image of that point, this is fx, and the image of that point is fy. Okay, and if we joining these 2 points by a straight line, okay, straight line, and if this line is below that curve and this f is your function, and this is the below the curve, okay, so this means this f is concave function. Okay, because this line is below okay, and this line is above. Okay, अगर वो straight line above है तो आपका convex function, otherwise this is your concave function. Okay, so here जरूरी नहीं कि कोई function which is convex नहीं है तो concave ही होगी, ऐसा जरूरी नहीं है। Okay, और फंक्शन को हमें देखना भी है कि जो फंक्शन है वो हमारी कॉनकेव फंक्शन कहेंगे तो हमारे पास दो चीज़ें हैं. फर्स्ट वन इज this property holds, means equation number hold, okay, and second one, the domain is convex. Domain is convex, okay. So if we take another example and if it write uh, convex function, next page, if we take, suppose if we take this type of function, if we write this is your any function f, this is a function f, okay, and if we take some points here, okay. So if we take any set S, that S equals to this AB union CD, okay, and this is your function f. This is your function f, okay. So if you take this point A and B, okay, so you have to say that this f convex or not. So you have to prove that, or you can say that this function is convex or not. Okay, so these are the functional value. तो आप ये बताएं ये फंक्शन मेरा कॉन्वेक्स है या नहीं. If we within this thing, this function is convex or not. क्या कहना है?
कॉन्वेक्स होना चाहिए सर, एबव ग्राफ के एबव में
कॉन्वेक्स होना चाहिए. ओके ओके. और कोई किसी को सबको क्लियर है या किसी को और डाउट है इसमें कि कॉन्वेक्स नहीं है? So this function is f not convex. Okay, f आपका convex नहीं है. क्यों? क्योंकि because this S set, this function which is defined on S, this set is not convex set. तो हमें दोनों चीज देखनी है. प्रॉपर्टी तो हमारी होल्ड करेगी, जो लाइन है वो एबव हो, और उसके अलावा हमारा जो सेट है, जिस सेट पे हमें डिफाइंड है, दैट सेट इज आल्सो कॉन्वेक्स. अगर आप देखें तो हमारा एक ये यूनियन ऑफ दैट है. ओके, सपोज इफ यू टेक वन पॉइंट हियर एंड वन पॉइंट हियर, इफ वी ज्वाइन दीज टू पॉइंट्स, ओके, सो दिस पोर्शन ऑफ line segment doesn't belongs to your set S. Okay, that's why your this given set S is not convex set. Clear? तो ये जब S आपका सेट जिस पे फंक्शन आपका डिफाइंड है, that domain is not convex, तो हम फंक्शन की कॉन्वेक्स की हम बात ही नहीं करेंगे. तो सबसे पहले हमें कॉन्वेक्स सेट आपने पढ़ रखा है कि व्हाट इज अ कॉन्वेक्स सेट. तो पहले हम फंक्शन की डोमेन को चेक करेंगे कि दैट डोमेन इज कॉन्वेक्स और नॉट. अगर वो मेरा डोमेन मेरा कॉन्वेक्स है, तब फिर हम ये नेक्स्ट हम इस पे जाएंगे लाइन सेगमेंट पे और देखेंगे कि वो हमारा कॉन्वेक्स है या नहीं. या मैथमेटिकली अगर आपको वो ग्राफिकल आपको व्यू नहीं है तो आप मैथमेटिकली आप प्रूव कर सकते हैं कि f ऑफ थीटा ऑफ x plus 1 minus theta of y is less or equals to theta of fx plus 1 minus theta of fy. ओके, लेकिन उससे पहले को देखना होगा कि ये फंक्शन आपका जो डिफाइंड है, दैट डोमेन शुड बी कॉन्वेक्स. ओके, तो ये चीजें हैं. नेक्स्ट है, थोड़ा स्टूडेंट इसमें कंफ्यूजन हो जाती है बच्चों को, सीधे वो फंक्शन को ही देखने लगते हैं, डोमेन को चेक नहीं करते. दैट्स व्हाई मैंने एक ऐसा डोमेन दिया. तो ऐसे बहुत से डोमेन होंगे जहाँ पे फंक्शन आपका कॉन्वेक्स तो दिखता होगा बट डोमेन आपकी जो है कॉन्वेक्स नहीं है. ओके, तो ऐसी कंडीशन में सबसे पहले आप देख लें, जब भी कॉन्वेक्स फंक्शन की बात करें तो डोमेन शुड बी कॉन्वेक्स। देन नेक्स्ट अगर हम बात करें कि हम व्हाट इज आवर अफाइन फंक्शन, बेसिकली अफाइन फंक्शन इज योर लीनियर फंक्शन। ओके, सो से दैट हियर ऑल अफाइन फंक्शन, जो अफाइन फंक्शन है, अफाइन फंक्शन मींस मेरा क्या होगा, अफाइन फंक्शन अगर हम एक ड्रॉ करें अफाइन फंक्शन, suppose, okay, so suppose this is a linear function, we say that this is affine function. Okay, so this affine function f, if we denote this function f, if there is any point, suppose x, and suppose this is y. Okay, so this affine function is convex or concave. Okay, या फिर दोनों नहीं है, नॉट कॉन्वेक्स nor neither convex nor concave. Okay, they are not convex and concave. Okay, तो अफाइन फंक्शन क्या होंगे? अफाइन फंक्शन अगर आप देखें तो हमारे पास if this set S, which is defined on this this set S, which equals to first interval of x, y. Okay, so you know that if we take this x and y on a real line, if we take any 2 points and we find that 2 points, that this is always belongs to that closed interval a and b. Okay, so that's why this is your convex set. So S is convex set. Okay, यहाँ पे सिर्फ हम AB की बात पूछें अगर कि this set on, if we define S1 is closed interval AB. Okay, so this means this function f is convex on S1. Okay, if we take the CD, suppose this is S1 interval, this is S2 interval, and this is S3 interval. Okay, so here f is also convex on S2, f is also convex on S3, and f is convex on S1 union S2 union S3. Okay, but not convex on this S1 union S3. Okay, so S1 union S3 ले लें तब convex नहीं होगी। ओके, तो ये सारी चीजें हैं। तो ये फंक्शन आपको चेक करने होंगे, दिस इज कॉन्वेक्स और नॉट, व्हिच इज डिफाइंड ऑन अ गिवन डोमेन। ओके, तो if we take this function f, which is a affine function, that is linear function, and here this set S, which is a closed interval of x, y, so this function is convex or concave or not convex, not concave. Okay, तो आप देखें तो यही कहता है कि if this function basically which is a linear function, ये आपके जो affine function होते हैं, इसका प्रूफ करना जाए, this affine function is both convex and concave. तो ये हमारे अफाइन फंक्शन दोनों ही होते हैं, बिकॉज क्योंकि ये हमारा जो है जो फंक्शन f है, दिस सेटिस्फाइज जो इक्वालिटी कंडीशन। इक्वालिटी कंडीशन जो है हमारी, इक्वालिटी कंडीशन क्या है, दैट इज द f ऑफ थीटा x प्लस 1 माइनस थीटा y। ओके, दिस इज लेस आर इक्वल्स टू थीटा ऑफ fx plus 1 minus theta of fy. Okay, so this means this equality condition is holds for all these points. Okay, that's why this function affine function is convex. Okay, and here if we take theta of x plus 1 minus theta of y is greater or equals to theta of fx plus 1 minus theta of fy. So here this inequality sign also holds for this affine function for all points. So that's why this function f is also concave. Okay, so this means affine function is both concave and convex. Okay. So this is simply due to affine function is always satisfies your equation number 1, and conversely that any function that is you say that any function which is concave and convex both, तो आप यहाँ लिख सकते हो conversely या यहाँ स्टार बना के लिखते हैं affine function is affine function uh, affine functions are both convex and concave, and conversely any function that is convex and concave is affine function. तो आप ये कह सकते हैं कि जो दोनों प्रॉपर्टी यूज करता है उसे अफाइन फंक्शन कहते हैं, और अफाइन फंक्शन के पास भी दोनों प्रॉपर्टी होल्ड करती है. ओके, और ओके तो ठीक है, इतना इसमें काफी. ओके, सो इफ वी डिफाइंड so next page we defined and standard value extension of any function. Okay. So next page, what is indicator function and what is the extended value function? So we define here simply the definition of that. So if any function f is convex, so its extended value extension, that is f tilde. This is for Rn to R union infinity. Okay. So this by, if we define this f tilde by this much, f tilde function, f tilde of x, this is defined as fx when x is belonging to this domain of f, and this becomes infinity if x is not belonging to this domain of f. Okay, so here you can prove that, or we can express this equation 1 for standard value expansion, extension f tilde for any theta lies between 0 and 1. This can be written as f tilde of theta x plus 1 minus theta of y. This is less or equals to f tilde x plus 1 minus theta of f tilde y. Okay, for any x and y. Okay. तो आप इसे देखें कि ये कैसे आप इक्वेशन नंबर 1 आप इस फंक्शन पे आप कैसे आप इसे डिफाइन कर सकते हैं. Similarly, second one is indicator function. Okay, so this is a real standard value extension function, and second one is indicator function. The second one is indicator function. So here, if we you have a set that is the element of Rn, and that set be a convex set. There is a convex set, and you consider the convex indicator, convex function, that is IC. Okay, the domain that is C, and this indicator function is equals to 0 for all x that belongs to that convex set C. Okay. So this is your indicator function, and we are interested to find the extended value extension of this indicator function. Okay, so its extended value extension is given by I tilde c of x, and this equals to 0 when x is belonging to that convex set C, and infinity when x is not belonging to that convex set C. Okay, so here you put that this convex function, that is IC tilde is called the indicator function of the set C. Okay. Similarly, you can define, if the outside from that is suppose minus infinity, so you can define a concave function by defining it to be minus infinity outside its domain. Okay, so here you can define the concave function also. Okay, so if the outside from that is if you take the minus in infinity, then this is your concave function, and if this is your convex function. So you can try it and show that this is a convex function or not. Okay, so here ओके तो ठीक है एक बज गए तो after 10 minutes you can rejoin and we will explore about what is the necessary and sufficient condition for any function which is a convex in that set. Okay, and then we prove that basically 2 to 3 theorems of in next class. Okay, and if the time permit me, so we can also introduce what is a hyperplane, okay, and what are the half planes. Okay, so at 1:10 you can rejoin, and this 10-minute break, after this 10-minute break. Okay, तो 10 मिनट बाद आप फिर से आप रिज्वाइन करें. ओके, तो 10 मिनट बाद फिर हम फिर से ज्वाइन हम करते हैं.